Hi, my name is Ed Gonzalez, and this is a presentation of my final project for course CSCI E63, Big Data Analytics, offered through Harvard University's Extension School. My topic is the ELK stack, and I will be using it to analyze data around public buses captured in near real time. Specifically, I will be looking at the speed and average speed of public buses across routes, distances, and time, in comparison to other buses on the same route. The average speed is an important measure that contributes to both customer satisfaction and overall cost of operation. The data for this will be pulled from the Chicago Transit Authority. They provide an open API where developers can retrieve a number of data feeds that cover information around bus locations, routes, and predictions. The primary feed that I will be using in my app is the Get Vehicles feed. This feed gives us access to some great data, such as bus locations, current speed, and vehicle ID. This feed is updated every 60 seconds, so we will pull this feed at approximately the same rate and store the data. This will allow us to provide near real-time reporting along with historical information for comparison and calculating averages. Because of constraints, I will focus primarily on one route, 151. This route can have as many as 20 buses running at one time, so this should provide plenty of information for us to analyze. As I mentioned earlier, I will be using a group of products referred to as the ELK stack. ELK stands for the three products in the group: Elasticsearch, Logstash, and Kibana. The three products are open source and are maintained by a company called Elastic. In addition to these products, Elastic also provides commercial add-ons and commercial support. I'll describe the products in the order that we're going to use them. First, we will be using Logstash to pull in our data. As the name implies, Logstash was originally designed for and is primarily used to process information from application and system logs. But it does such a great job processing event data that it is now routinely used to process data from many different sources. In our case, we will be pulling data from the Chicago Transit Authority API. Logstash can also stream the data to many different locations. And of course, we will be streaming our data to Elasticsearch. Elasticsearch is a search server based on another product called Lucene. It indexes and stores data as documents in a somewhat schema-free JSON format. Finally, at the end of our pipeline sits Kibana. Kibana is on top of Elasticsearch and allows us to explore the data using queries and a set of powerful visualization tools. Elasticsearch also provides a very rich RESTful API that we can use to query, update, and index our data using JSON over an HTTP client. In order to test this, I'm going to use d3.js, a very popular and powerful visualization library to visualize the data we get through this API. Now, I created and am running this application on a virtual machine with CentOS 7 version of Linux installed, with 2 processors and 8 GB of RAM. Now, this was a personal preference. These products will run on Windows and Macs. Installation was easy and simply involved downloading the files and running a few commands. Since I'm on a simple environment, I did not do any other configuration and just accepted the defaults. Now let's take a closer look at our data. Again, we are pulling data from the CTA, and we can get this data using a URL. In the URL, we specified the feed we want. In our case, it's the Get Vehicles feed. We then pass 2 simple parameters, a key and a route filter. You will need to obtain your own key from the CTA website. The data itself comes through as XML, with an entry for each vehicle currently running on Route 151, and information about each vehicle is contained within its entry. That information includes the vehicle ID, the timestamp indicating when the vehicle communicated this information, its location in terms of latitude and longitude, the pattern ID, and the route. Now, the pattern ID is the actual path the bus is running, the bus's or vehicle's final destination, the distance the bus traveled along this pattern, the speed of the bus, and the trip ID. Now, the trip ID is important because this particular vehicle may run the same pattern multiple times in one day. Now that we know what our data looks like, we can create a Logstash configuration file. This file tells Logstash how to handle the data. It has three main parts: the input, where to find the data and how to get it; the filter, how to process the data; and finally the output, where and how to send the data. In my input, I tell Logstash to use a plugin called HTTP Polar and give it the same URL we used for testing, and then set the timeout and the frequency to pull the data. In our case, we are pulling the data every 60 seconds. Our filter section is by far the biggest, so just to highlight, we tell it that our data is in XML format and how to parse it. And then finally, the output section. Of course, we tell it to send it to Elasticsearch, but we also tell it what index to use, which is basically the text CTA-API and the current date. What's important here is that this index is based on a template that we will create in Elasticsearch. Finally, in Elasticsearch, we create an index template. By default, Elasticsearch will treat every field as text and index every word in the text. So we define an index template to tell Elasticsearch to treat our numeric fields as integers and to index text fields as a whole. And then most importantly, we set the template name as CTA-**. This way, these rules will apply to any index with a name beginning with CTA-, like the indexes we create in the Logstash configuration file. Okay, now that we have our configuration set, we can jump right into the front end, which happens to be Kibana. Now, Kibana has four specific tabs, or four main tabs, I should say. We have Settings, Discover, Visualize, and Dashboard. Now, Settings is where we come in and we configure the indexes we want to use to query and to visualize. I've already been in here, so I set up the index CTA-*, meaning any index that has CTA- will be available to us for querying and for visualization. The Discover tab is where we actually view our data and where we can filter our data and do some querying our data. Now, a couple important things on here is, first of all, our time frame. By default, I have it set to look at the last 15 minutes, but we can set this for the full day, for the full week, or for relative time periods like yesterday or last week. We also have available to us some statistics about our data. We can see how much data we received over the last 15 minutes broken out by minutes. So we can see at 9:15 we received 12 records, and at 9:14 we received 15 records, and etc. down the line. We see a list of our fields available to us, or the data that's available to us, sorted by most recent at the top. And if we look at the very first one here, we have a timestamp of 9:16. And if we compare that to my system time, we can see that it's pretty close. I am at 9:18 and our latest data is 9:16. So it's relatively quick data. But if you remember, Logstash is updating every 60 seconds. So we can set this web page to update automatically for us. So if we click on there, we can set the auto refresh rate to 1 minute. So now our web page is going to update every minute, which should be pretty close to what we have set in Logstash. So now if we look, our latest timestamp is 9:18 compared to my system time 9:18. So very fresh data. Now there's a lot we can do in the Discover tab, but because of time constraints, I want to jump right into the visualizations. So if we go to the Visualization tab, we can see that Kibana offers us a number of very nice visualizations. And it's a pretty powerful tool. We have our basic charts, line charts, data tables, pie charts, and so forth. But one thing that's pretty cool is that Kibana right out of the box provides us a map for geographical plotting. So we can create a map visualization right out of the box. So let's go ahead and try a couple of visualizations. I'm going to start with a line chart. I'm going to start with a new search here. So by default, Kibana aggregates everything to a count. So we want to change this. And instead of count, what we want to see is average speed. Now we don't have any filters on here, so we're looking at all buses that are communicated to us within the last 15 minutes. So for our x-axis, what I want to change this to is I want to show a date histogram, and I want to show the interval by minutes. So now if we run this, what we see now is the average speed over the last 15 minutes, starting at 9:06 to 9:19. And we can see that the average speed goes up and down. And now again, this is for all buses currently running on Route 151. So if we look here, our average speed was just a little bit over 12 and a half miles. Again, 12 and a half miles. Our fastest speed was 18.6 miles, or our fastest average speed. So that gives us a quick view over the last 15 minutes what our average speed has been. So let's go ahead and let's save this one. And we're going to save this one as average speed line. Let's go ahead and save that one. Okay. And now let's go ahead and create a new visualization. And this time we are going to pick the map. Again, we'll start from a new search. And then once again, we want to change our value to average speed. So let's go ahead and change this to average, our field to speed. All right. Now for our buckets, we wanted to use geo coordinates. Since we only have one geo coordinated field, which happens to be location, that pops up automatically. The only other thing I want to do in here is I want to change the precision so that it's always at 7. And I'll explain that to you in just a second. Now if we run this, okay, we don't really see much yet. That's because we're zoomed out so far. But if we click our fit bounds, we'll zoom right into Chicago. Now this is a little hard to see because I'm zoomed out so far. But before I zoom in, let's go ahead and change one more option. Instead of scaled circles, I want to switch this over to a shaded geohash grid. What that will do is that'll create a grid of squares for us to view. Now if we run this again, now let me go ahead and zoom in so we can see what this looks a little better. Okay, and it's a little far, but that's okay. So each one of these grids represents a little bit more than a block, maybe a block and a half worth of space. And the shading represents our average speed. So the darker the shade, the faster average speed. So that was a quick clip of 35 miles per hour within this block and a half. And we can see where we got a little slowdown at 5.75 miles an hour in that little shaded area or that block and a half. So now we have a lot of different options for mapping and creating map visualizations in Kibana. But I wanted to show this one real quick just to show how fast and easy it is to create a map visualization. So what I want to do now is let's go ahead and save this one. And we'll save this one as map 2, since I already have a map 1 there. Save that. Okay. Now, if we wanted to share these or we wanted to make these visible to us whenever we came in here, we can create a dashboard out of these visualizations. So now that we're in the dashboard tab, we can go ahead and click the button here and we can start combining some of these. So let's go ahead and start by adding map 2 and then average speed. Okay, let's go ahead and just format these up a little bit better. I'm going to go ahead and I'm going to take the average speed and make this a little bit bigger. And then let's go ahead and take our map and extend that just a little bit more. Okay, and I'm just going to zoom in just a little bit just so we can get a little better view there. So there we are. Now we can save this and we have a dashboard and we have 2 visualizations. We can see average speed broken out by small block sections. So every block we can see, or a block and a half, we can see what our average speed is there along the route. And then on the right hand side, we can see what our average speed is across time. And again, we are filtered on the last 15 minutes, refreshed every single minute. So that's it. that barely scratches the surface of what we can do with Kibana, but I wanted to save a little bit of time so that we can explore the Elastic API. Right, so now let's take a look at both the Elasticsearch API and a sample of the Elasticsearch query language. As I already mentioned, we can use the API to query, update, and index data in Elasticsearch using an HTTP client or simply using a URL. To test this, I will be using the client-side URL tool in Linux and then show what the query looks like in my JavaScript that I use in my HTML page. Once we get there, I will not go too deep into the code. I just want to show what this actually looks like in real life. So on the screen right now is the curl command. And to the curl command, I pass the URL to the Elasticsearch server, which normally runs on port 9200, plus the search command. And then next comes the actual query. Now, one thing I found is that I can actually structure this query in a few different ways to get back the same data. This just happens to be the way that I queried and found it to work for me. First, I used the match command to match route 151. And second, I use a filter of type range to get data between greater than or equal to now minus 2 minutes or less than or equal to now. And then finally at the end, this is just personal preference. It's a Python command that I use to format the data so it looks nice when I run this in the terminal. So let's go ahead and copy this out and run this in the terminal, and we can see what we get back. So paste that there, and then we hit enter, and then boom, we can see that we get data back pretty quickly there. Let's scroll up near the top, or actually just anywhere where we got an entry, and we can see what we got back. So this is a single record or a single vehicle in our case, and we get the vehicle ID, the trip ID, the speed, what route it's on and what pattern, the location, and importantly the timestamp, which happens to be 1403. And if we compare that to my system clock, 1404, we can see that it's pretty recent data. So that's basically how we get the data back. Now I'm going to use the same query in my JavaScript, and we're going to use the same output to parse it and display a visualization in an HTML page. I created 2 HTML pages where I generate maps and visualizations using D3 and Leaflet to display the data we get back from the API call. The first page uses basically the same query that I just demoed, which happens to be right here. And you can see that it looks basically the same. The major difference here is that I have this query embedded within a bigger function, and second, I do not hard code the route. Instead, I get that passed through the function. Next, I assign the URL to the Elasticsearch server to a variable. And then finally, I pass both the URL and the query to jQuery's AJAX function to process the data and make the call. On the second page, I use basically the exact same process, except my query is different. Here, the major difference is that my query takes 2 filters. One is for vehicle ID, and the second one is for trip ID. And the structure of the query is slightly different as well. I am now using a Boolean filter function in order to match both filter properties. But same as the other page, I am assigning the URL to a variable. Then I pass both the URL and the query to the AJAX function to process the data and make the final call. Now, as I mentioned earlier, I'm not going to go too deep into the code, or I'm not going to go into the code at all here. I just want to show how it's basically used. So the first page is this one here, all buses by route. If I click on this, what I see here is that my AJAX query made the call, brought back the data, and I used D3 and Leaflet to create a visualization. On the map on the right hand side, I have a dot for each bus that is currently running the route. And it looks like I'm missing a few, so if I zoom out here just a little bit here, yep, I was missing a couple there. I can actually go back in a little bit here. make that just a little better viewable there. Anyways, as I mentioned, I have one dot for each bus that is currently on the route. And that dot also corresponds to the legend on the left-hand side. So if we take a look, for example, at green here, if I hover over green, I can see the dot gets highlighted on the map as well. Same with orange and pink. Now on the legend itself, I added some additional information here. I have the bus ID, the trip ID, the time that we last communicated with the bus, and then once again, just to compare, I can see that the time that last communicated was 14:25, and if I look at my system clock, 14:27, pretty recent data. But at this point, I probably have some new data, so if I were to go ahead and refresh there, I can see, yes, that we now have data for 14:26. Now, in addition to the time, we also have the speed and the final destination. Now, as I mentioned, this shows all the buses currently running on Route 151 and their current speeds. Now, if we wanted to look at one specific bus and see what the average was for that bus along this route, I can go ahead and pick one. So I'm going to take a look at the red one here, and that seems to be a bus with vehicle ID 4028 and trip ID 284. If I were to click on this, I first get a debug alert box here, and I just click through that, and that passes the information, it passes the vehicle ID and the trip ID to this next page, where I can see that I'm looking at average speed for Route 151, vehicle 4028 with the final destination of Belmont and Halstead. It's currently running a pattern that is 32,451 feet long. Now let me scroll down here a little bit so we can see this a little bit better. Now on the right hand side, we can see a legend that shows our speeds broken down by 0 to 6, 7 to 12, 13 to 18, 19 to 24, and finally 25 to 30. Now by hovering over these, we can see where we actually hit those speeds. So let me keep scrolling up there. So if I hover over 0 to 6, we can see that we hit 0 to 6. We were going pretty slow a lot during this trip. 7 to 12, we only hit a couple times. 19 to 24, only 3 times did we actually hit that speed. And 25 to 30, not many at all. Now this first line here represents the entire path in feet. So we can see that this particular bus is a little less than halfway through the entire path. And we can see each dot represents one time that the bus communicated with us. And we can see at the time that it communicated it, where it was in the pattern and how fast it was going. And we can see that as well in the map. So we can see it geographically. I apologize for that. Keep scrolling back up there. We can see it geographically on the actual path in a map, and we can see it in a simple linear format so that we can get a good idea of where it is. And then that's basically all I have so far. It needs a little polishing up, but the point here was really just to show that we are able to query the Elasticsearch server, return data, and then use that data either to make visualizations like where I'm showing it right here on the screen, or to incorporate into third-party applications. Well, in closing, I would have to say that overall I really liked using the ELK stack and the tools that it incorporates. The only piece that we didn't really get a chance to test out was its scalability. How is it going to perform if we try to pull in multiple data feeds, if we try to increase maybe the frequency of our data feeds, or increase basically the size of our database across multiple servers. Now the documentation says that it should be able to handle it pretty well. We just didn't have a chance to test it here in this proof of concept. As far as Logstash is concerned, I think that it's a great tool. I look forward to using it in the future against different data sources and testing it out. Elasticsearch was also a very good tool. I'm not quite sure if it fits in, if we were
in the way that we were using it as a general data store. It is designed for documents and indexing large textual information, but it did perform pretty well, and I think the API is really great. Kibana, very quick visualizations, very easy to explore the data. I do think that if you want very complex visualizations, particularly very specific mapping, you may have to step outside of Kibana the way I did using D3. Uh, but still very useful, very quick dashboards, very easy way to explore and share your data. And that's it. I hope you enjoyed it. And if you have any questions, please reach out to me. Thanks.